Hello everyone, welcome to another session of solid state. In this session, I will be explaining you about crystal lattice and a unit cell. So without wasting any time, let's move on to it. So crystal lattice, a regular three-dimensional arrangement of points in space is called a crystal lattice. So points, basically these are the points. For us, these points represent an atom. So there are only 14 possible three-dimensional lattices. These are also known as Bravais lattice and have the following characteristic that each point in the lattice is called lattice point or lattice site, and each point in the crystal lattice represents one constituent particle, which may be an atom, a molecule, that's a group of atom, or an ion. The lattice points are joined by straight line to bring out the geometry of the lattice. So this is a typical example of a unit cell. Now, unit cell is the smallest portion of a crystal lattice, which when repeated in different direction generates the entire lattice. So this you see is a unit cell, and if you see in the previous diagram, this highlighted box is your unit cell. If you repeat this in all the three dimensions, that is x-axis, y-axis and z-axis, you will generate the entire lattice. So a unit cell is characterized by the following points. The points are actually its dimension along the three edges, that is A, B and C. So you can see this A is the length here, this B is the other length, and C is the third length. And they can be mutually perpendicular or may not be mutually perpendicular. So it's not compulsory that they are mutually perpendicular to each other. And the angle between the edges, that can be alpha, which is between B and C. You can see alpha is between B and C, beta between A and C, and gamma between A and B. So these are the 6 parameters. So unit cell is characterized by 6 parameters, that is A, B, C, these are the length, and alpha, beta, gamma are the angle between these lengths. Now we will focus on the following crystal lattice. So primitive and centered unit cells. So primitive unit cell means the constituent particles are present only in the corner position. So you see that this is a corner position, this is another corner, 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 all these are corner positions. Okay, so if the constituent particle is present only in the corner position, it is called as primitive unit cell. Then centered unit cell are of three types. So centered unit cell meaning that at the center a unit cell is present. For example, in body centered unit cell, the unit cell contains one constituent atom at its body center. Like where is the entire body of the lattice? Let's say that this is the body of the lattice. At the center there will be an atom. Face-centered unit cell. The unit cell contains one constituent particle present at the center of each face besides one that are present in the corners. So this is one face. Okay, the center of this face is this part here. So consider this as your face, and it is present here, the face center. Next is end-centered unit cell. In such a unit cell, one constituent particle is present at center of any two opposite faces besides the one present at its corner. So it is present at center of any two opposite face. Okay, like in this case, let's consider this as one face and this as opposite face. So one is present here and the other is present here. Okay, so one constituent particle is present at the center of any two opposite faces besides the one present at the corner. So that is end-centered unit cell. In this session we will focus only on primitive unit cell, body-centered unit cell and face-centered unit cell. So this is a cubic lattice, you can see. Okay, so everything is like all the angles are 90-degree, the length A, B and C are all equal. Then this is tetragonal. So basically the idea here is like apart in A, B and C, alpha, beta and gamma, if you change any one parameter you get a new unit cell. So these all are different unit cells. So these are 7 primitive unit cells in crystals. Okay, so you can just observe what is different. Everyone is different than the previous ones. these are the details. So basically, if you see in cubic, A equals to B equals to C, alpha, beta, gamma are all 90°. These are the examples, that is NaCl, zinc blend, Cu are example. Tetragonal, A is equals to B, not equals to C, but the angles are all same. So if you see between cubic and tetragonal, you see angles are all same, just B is not equals to C. That's the only difference. In orthorhombic, you see A is not equals to B, not equals to C, but all the angles are 90°. And these are the examples. So if you see, there is only one difference. So basically, if you see these parameters are the main determining factor. So based on that, we have 7 primitive unit cells. Now this is a simple primitive unit cell, that is the atoms are present only in the corners. This is a body center, that means that this is the unit cell. At the center we have the one constituent particle. Face centered, that means all the 6 faces are having one atom at the center. Okay, so these are the tetragonal ones. This is the cubic lattice, that is tetragonal. Similarly here, these are orthorhombic lattice and 2 monoclinic lattice. Okay, so and here are the other hexagonal lattice, and then rhombic lattice, then triclinic lattice, all are represented in this way. Now let's focus our attention on number of atoms which are present in a unit cell. Now if you consider primitive unit cell, that is this one, so each atom which is present at the corner is actually divided into 8 unit cells, that is this one here, 1 2 3 4, and same 4 at the bottom, because this one is present in the corner. Like this atom here, this one which is represented also here, is 1/8 of it. Okay, so each atom at the corner is shared between 8 adjacent unit cells. So only 1/8 is actually belong to a particular unit cell. So basically, if you cut it, you get the structure C. So you see there are 8 corners, and each corner contains 1/8 of the actual atom. So in case of body centered, the cubic unit cell, how many atoms it contains? So the body center BCC is also known as BCC unit cell, has an atom at each of its corner and also one at its body center. So 8 corners into 1/8 per corner gives you one atom, and one present is at the body center, so another atom. So total number of atoms present in a unit cell is 2 atoms of BCC, that is body centered cubic unit cell. Next, for face centered cubic unit cell, 8 present in the corner. So you can see 1/8 into 8 gives you one atom, and 6 faces are there, and each face contain half atom per unit cell. Basically, if you see, this is your unit cell here, okay, this part. So this atom is shared only between this unit cell, this unit cell and this unit cell. So that's why this is actually half atom is present in this, and since there are 6 faces, multiplied with 1/2 atom per unit cell gives you 3 atoms. So in total there are 4 atoms present in FCC. Okay, so that's all for this session. Thanks a lot for watching. Thank you.